translate the name of the service, so Canon MP380, into the IP address that you're going to talk to and port. So once you get a net service back from did find, you set yourself up as the delegate if that's the one that you want to connect to, and then you call resolve. Resolve with timeout, same as resolve, but of course, with the timeout. And you'll get notified when it did or did not occur, right? So if the timeout occurs, you'll get a did not resolve. And if it actually was able to translate the net service into an IP address, you get the net service did resolve address. And it's the same service you get back, but now is populated with IP address and port, so you can go ahead and communicate. Yeah, and again, once you're resolved, you can go ahead and talk to the service. So let's take a look at that really quick. So I have a real simple example, actually. Let's see, found, was this one? All right, so what I have here is I have an application that as soon as it launches, it advertises itself on the network. At the same time, it presents a table to you, a list to you, of all of the devices that it found on that network. And I have I'll show you on an iPod Touch here, where it's running the exact same application, and it's using, over Wi-Fi, it's going to find the service that we're running a simulator and allow you to connect to it. So let's look at the code. Down in our app delegate, let's actually ignore that receive server. We're going to look at that in a later example today. But all we do, of course, is we take our view controller, we stick it in our window. Nothing special there. But the view controller is actually this guy, found devices table view controller. And let's look at what the implementation here is. When the view comes into, when the view is about to appear, it calls, it creates a browser, it sets itself as a delegate, and it searches for services of sampleservice.tcp. In domain, no string, which means we're going to look for local instances of this service. In view will disappear. We're going to tear it down. Okay. And now down here in the net service browser callbacks, there are 3 different callbacks we've implemented. The first is did find service. Okay. When we find a service, we're going to, we'll create a found services array in case it doesn't already exist, and that's defined in my header. We'll add the net service to the found services list, and then we'll tell the table view to reload. This is a table view controller subclass, by the way. In the did remove service, we're going to take that service out of the found services array, and when we stop the search, we'll just remove all the objects in that array. Down in our table view population, let's look at what we do here. So of course, every time one is found, we reload. We're going to say number of rows in section is the number of rows in the table, is the number of found services. And cell for row at index path is going to actually create one cell for each found service. So this goes standard stuff here. We create a table view cell. Sorry, we try to DQ one. If we can't DQ one, we create one. But here we get the net service out of the found services array that corresponds to the index, and all we're going to do is set the text of the cell to match the name of the service that's advertised. Actually, one thing I do need to point out in the receive server, this is where we actually start the Bonjour net service. Right? So this is where we're actually going to do the advertising of the service. So I'll spare you the details of a lot of this stuff. But essentially, so in our app delegate, we created an instance of this object we call start server, which goes down to here. And don't worry about a lot of this stuff. This is standard networking stuff. But the interesting piece is, and none of that stuff is needed, actually, just for the advertising. That's going to come into play a little bit later. But this is where we're actually advertising the net service. So if we were actually able to open a port that we're going to use for communication later, we go ahead and we create our net service with the sample service type, and the name of our service is going to be the name of our device. And the port's going to be whatever port we got back out of the networking code above. If that was successful, we're going to set ourselves as the delegate, and then we're going to publish with options You can actually just call publish here. And that would actually start up our advertising. So let's see what that does. And just for balance, in our stop server, we call net service stop and clear out the net service. So one class, once again, when we launch the application, it's going to advertise itself as a presence, and then it'll present you a table of all the items it found. So let's just start by running. All right, so there it is. We have an application that found one instance of the service, and it happens to be itself, right? That app came up, it advertised itself, and then it's listing all the ones it could find, including itself. Now, if I run the same application on the phone here, and make sure I'm on the network, what we should see is as soon as this launches, or a fraction of a second after, we should see this device show up in the list. So here I go, I launch. I just tried this like 10 minutes ago. There we go. There we go. So, right, so Alan's iPod, this guy, as soon as it came on the network, it advertised itself via Bonjour. It says, hey, I'm available. And then this guy is still listening. He got or did find net service, and added it to his list and reloaded the table view. So that's it. If I quit this, all I do is quit the app. We should see it go away. Maybe some network lag. But it will go away, I promise you. There is some caching that goes on, so sometimes it takes a little bit. But yeah, it will come off. You saw it come on, so you can believe me that it's going to come off. All right, let's look at the next part, which is how do you actually communicate? So you found the service. Now how do you actually send data back and forth? It's not really that interesting to just have a list of services available. You want to actually do something with that. So let's get back to where we were. So we're going to talk about NS streams. All right, NS streams is a convenience class that wraps sockets. Right, so for those of you that are familiar with networking code, sockets are a way for two processes to talk to each other, whether they be on the same machine or on different machines, and they communicate via a port. We're going to use NS streams as a way of doing this, which are conveniently very well supported in NS net service. So if you can actually ask for an input stream and an output stream from your NS net service. So this is it. Right? You have two variables, input stream and output stream. When you got a net service, when you received a net service and you successfully resolved that net service, which means you got an IP address, you can go ahead and get the input and output streams so that you can send data back and forth. It's a lot like sockets. It's a little higher level. The changes are asynchronous, once again. So you set yourself up as the delegate on the stream, and it will call you back with, there's only one method it calls you back with. Writes are still synchronous. Sorry, state changes are asynchronous. So the coming and going of connections is asynchronous. The writing and reading is actually synchronous in this case. You can have several streams, and they're used for different things. You can use them for writing the files. You can use them for network activity. So NS stream is a subclass of NS object. And there are two subclasses there that we care about. One is NS input stream. One is NS output stream, as you can probably guess. NS input stream is useful for getting data from another process. NS output stream is for sending data to another process. When you open a stream, all right, so in our case, we're going to get the stream from the Bonjour net service. You set yourself up as the delegate. And then you call this method called schedule in run loop. And you may have seen this with other objects as well. And I'll talk about run loops in a second. But you need to schedule your stream in a run loop so that you can get events from it, so that it can read from it, write to it, and so that you can get callbacks about it. So once you've scheduled in the run loop, you call open, and that actually initiates the connection and starts data transfer. Closing a stream is just the opposite. You close it, then you take it out of the run loop, and you clear the delegate. So what's a run loop? Well, we've already talked about run loops in terms of touch event processing.